Okay, in this lab here, we're going to be creating a voltaic cell. The solutions we're going to be using here is a copper-2 sulfate solution. We're going to be dropping a copper solid electrode inside. Our other half cell is going to be made of a zinc nitrate solution using a zinc electrode. Hopefully by running the spontaneous reaction here, we can generate some positive voltage out of this. This is pretty much the inner workings of a battery here. We know steadily as you run batteries for longer, as the chemicals steadily degrade away, we're going to steadily lose voltage and then drop back down to zero. But what we're going to try to do, we're going to try to keep the concentrations fairly high to begin with so we can make some qualitative comparisons. So I'm going to start off here with this copper-2 sulfate solution here. We're going to scoop an amount of this copper sulfate. The exact amount here doesn't matter. I just want to make sure that there are copper ions that will be in solution. For the other side here, we're going to be using our zinc nitrate solution in a similar fashion here. I'm just doing this fairly qualitatively here, so I'm just going to scoop in a little bit of zinc nitrate there. I'm going to dissolve both beakers in a little bit of water. If I add too much water, the solution here will be fairly dilute, so it's actually not going to have the highest voltage that we want. So I'm just going to have enough water inside. Eventually we are going to be putting our U-tube inside this, so we want to make sure that our solution is deep enough that our U-tube can actually be connected to these two solutions here. So just let me stir these up a little bit here, try to help out with the dissolving. So as that there continues to dissolve away here, just going to demonstrate how we're going to be using this U-tube here. So here we have a glass U-tube. Okay, this is the real U-tube here. We're going to be filling this with a salt solution of potassium nitrate. Potassium ions and nitrate ions are so low oxidation and low reduction potential that they don't interfere with our reaction, but they do generate the ions to help us maintain electrical neutrality. So this part here will act as our salt bridge for us here. First, we're going to start off with our U-tube right side up. I'm going to fill in our potassium nitrate solution here. You want to make sure you fill up the solution all the way to the top. Okay. Because eventually, when we actually top this U-tube here upside down, I want to make sure that the solution is actually connected near the top. Now before we flip this upside down to hold the solution inside, we're going to take these cotton balls here. Sometimes they're a little bit too large, so you can rip them up into smaller pieces here, and all you want to do here is you want to plug up one side and plug up the other side, and that way the solution should be able to just stay inside when I top of this U-tube over. The cotton ball will be soaked up with the solution and therefore help connect the two containers. So I'm just going to just tilt this upside down here. The part I was mentioning here, you want to make sure you fill up the U-tube here completely. You want to make sure that the solution is actually connected to the top. If the solution starts leaking out on the bottom here, this is the first part that's actually going to be disconnected. So right now here it looks good. The solution is all the way up here. I'm just going to prop it up here. Be careful, sometimes the U-tube here does sort of topple over, so I just want to be careful as I prop that up there. The salt bridge sort of acts like an on-off switch. If we can't maintain electron neutrality, no reaction is going to happen. Right now there also is no voltage because I haven't yet put in our electrodes yet here. If everything goes according to plan here, when I drop these electrodes in, electrons should be moving from one half cell to the other half cell. I'll let you figure out which is the oxidation and which is the reduction, and we're going to make some comments on voltage. So I'm just going to put the copper electrode here in the copper solution. Hopefully that's all dissolved now. In a similar fashion here, I'm going to take my zinc electrode here and put it in a zinc solution. Okay. Make sure that there's a good contact between the electrode and the solution there. Okay. And we're getting this reading here. Right now I have my multimeter here set maxing out at 2000 millivolts as a DC current. So if it says 2000, it would be 2 volts. This one here is currently 0.6 volts. You'll notice there's going to be slight fluctuations here. That's going to be as the solid actually dissolves, there's a little bit more concentration. Some of those particles will start losing electrons, gaining electrons a little bit better, but we're just going to take down a sort of middle reading here and then associate an error. So currently we're at 0.6 volts, or if you want millivolts, you can just say 649 millivolts here. For our multimeter here, I've connected the one end here to the voltage setting, the other one is a common ground. It really doesn't matter which alligator clip you use as red or black, that's just a plastic coating. That's just for you to be able to distinguish the two there. But there we go, we've created a voltaic cell. This is essentially what's happening inside of a battery, and as the chemicals start reacting away, as those electrons get transferred, because the electrons are moved from one side to the other side here, we're able to tap that electrical voltage as the electrons go from one half cell to the other half cell. Okay? So Last thing I want to show you here is, so we've generated a battery here, we're creating 0.6 volts or so here. I want us to just investigate the effect here. What if I take some water here and I dilute each of these respective sides? We want to see what happens to this voltage here. So I'm going to start off here by adding a little bit of water to our zinc solution. So I'm just going to pull this back here. So right now we're about 640 or so. Just going to dilute this side. We'll see if there's any changes on the multimeter. You see that millivolts here has increased a little bit here. There's a little bit of fluctuation because I sort of knocked the electrode as we were going here. And in a similar fashion here, let's add water to the other side here. Try not to knock over my YouTube here. And as we add that water to this side here, let's see if we can see any changes to the voltage. Okay. And there we go. So I'll let you see if you can investigate the individual equilibria to figure out why there were these changes here in the voltage, but that pretty much is the inner workings of a battery or a voltaic cell. Thanks, guys.